Hi, everyone. Welcome to the latest installment of our ongoing editorial webinar series, Coffee Talk. Each hour-long information-packed episode features observations and insights of an independent expert on a wide range of tech industry topics. Many thanks to the underwriting sponsor of this episode, high-performance enterprise networking solutions provider Juniper Networks. Without their support, this series would not be possible. And thanks to you for joining us. I'm John K. Waters, Editor-in-Chief in the Converge 360 Group of 1105 Media, and I'll be your moderator. Today's topic is Top Enterprise Network Trends for 2023, and our main presenter is technologist, creator of compelling content, and senior resultant, Howard M. Cohen. Before we get started, just a bit of housekeeping. This episode is being recorded for later access. Keep an eye out for an email with a link to that recording. It'll be coming your way in the next few days. We'll make some time during the talk for some questions. Please feel free to type your questions into the Q&A box at any time. On the left-hand side of your screen, you'll see some extra resources provided by our sponsor. Be sure to check those out. And as a small thank you to the first 250 attendees who stick with us to the end, we'll be sending you a $5 gift certificate to Starbucks. It's a cup of joe to go with the info. Now let's meet our first presenter, Howard M. Cohen. In his 40-plus years in the IT industry, Howard has held senior executive positions in many of the top channel partner organizations, and he currently writes for and about IT and the IT channel. Howard is a sought-after speaker, an insightful observer of the technology landscape, and one of our favorite presenters. Take it away, Howard.
Thank you, John, and thank you for that introduction. How many of you noticed that John missed the word wireless? It's Top Enterprise Wireless Networks for 2023. I was nervous. I was like, I've got the wrong presentation. But no, I do have the right presentation, thank goodness. And let's get started with the word of the day. Those of you who have attended any of my presentations in the past know that as a writer, I love words, and I love to start with a word of the day. Today's word is bandwidth, because wireless is all about bandwidth. How much bandwidth can we provide? How broadly, what kind of geography can we cover? So many things. It's all about bandwidth, and all the metrics are in bandwidth. So let's get cooking. Okay, first generation of wireless services from about 1970 to 1980 really only focused on analog voice. You may remember the flip phone, the brick, the StarTech. There's all kinds of phones. They were phones, and they worked fairly well over time. So I myself had a car phone, and I thought that was so cool. Soon, we got to the second generation, 2G, and that brought us digital voice, which was much clearer, much crisper. And we also got messaging services, so we could key our messages to each other. You may remember having to hit the numbers 1, 2, or 3 times to get each letter. That was a lot of fun. Okay, then there was 3G, which from 1900 to 2000 combined not only voice and messaging, but also data services. You could actually start to browse the web, kind of, on your phone, and that was amazing, which of course gave way to 4G LTE, which shifted the focus to all of the IP-based broadband services. Now, the mobile phone became the real expression of Alan Kay's original Dynabook vision back in 1974, 72. Alan Kay described a device that you could carry with you. He did refer to it as a personal digital assistant. He called it the Dynabook, and it could get you any information you needed from anywhere in the world instantly. Now, he had a couple of years' knowledge of the existence of the internet at that point, but it was a tremendous vision all the same. Now you had it in your hand. Okay, well, we've gone through 4 generations of wireless services, which brings us now to the 5th generation, 5G. 5G. And Today, we're going to talk a little bit about what's happening with 5G, because certainly in 2023, it's all going to be about 5G and Wi-Fi. Okay, so let's start off by describing what 5G is for. What is 5G? It was designed to provide higher data rates, faster bandwidth, more bandwidth, faster. Everybody wants to go faster and faster and faster, and it does. Something that is very seldom mentioned is that it's meant to increase energy savings. So there's not as much of an energy draw from, again, it's all about the carbon footprint. Expanding system capacity to give it more functionality. Enabling, I love this phrase, massive device connectivity. Now, just say the words Internet of Things, and you know what they're driving at with that phrase. Enable massive device connectivity. So we're going to have sensors and controls and switches and all kinds of devices all over the place, as Carl Sagan used to say, billions and billions of them. And 5G was designed with the idea that we could support all those devices. And the thing that everybody thinks of first when they think of 5G is that it's going to reduce latency, which would be great. And of course, everybody's favorite, it's going to minimize costs. Costs will be lower with all this better functionality. That's the best part. The idea is to deliver highly reliable communications for multiple, simultaneous, mission-critical applications. Wireless is being taken very, very seriously. It's going to support everybody's mission-critical workloads, and the anticipation is that there's going to be lots of them. So 5G is really designed with the future in mind. It's also designed to provide a powerful and programmable network. This will support time-sensitive applications, higher capacity needs, and the most important one, I think, is edge computing, going back again to the Internet of Things, when all of that, all of the real rubber hits the road is happening out at the edge of the network. The core is still there, it's still needed, still necessary, but all of the devices are at the edge. And so we've got to figure out creative ways of managing them, of connecting them in the first place, of monitoring them, and we need sufficient bandwidth to do all that. 5G was designed with that in mind. Increases in 5G small cell coverage. Small cell. We're going to talk about small cell later, but basically small cell means you're deploying antenna all over the place. And each one serves a small area around it so that it's all concentrated. Now, it's much more backhauling to be done, but what you get is far better coverage, far better access, far better bandwidth. And again, it's supposedly easier deployment and lower energy consumption. We'll talk about it later, but the big application here that I think of always is smart cities. And another prediction that I ran into is that 2023 will see the first 5G implementations, and they're going to allow users and enterprises to fully experience the power of the technology at scale. The emphasis is purposeful. It is going to be the first 5G implementations in 2023, and I'll explain that momentarily. And to fully experience the power of the technology at scale, we're not there yet. That's the thing you have to remember. You're seeing 5G being rolled out, but it's not fully 5G. So a couple of highlights. First of all, in a survey of IEEE members, more than half named 5G as one of the top 5 technologies in 2022. So the IEEE is paying very close attention to these developments. They anticipate that the biggest impacts will be in remote learning and education, telemedicine, entertainment. I think they've left out quite a few, but each of these definitely cries out for better bandwidth, more reliability. Well, except entertainment, but yeah, if you're watching a movie, you don't want that movie to stop now, do you? Also, 5G will enable remote collaboration, remote operations, remote management, and remote services. It'll drive costs down, and it will accelerate communications. We have these today, but they're going to be redefined for us in the age of 5G. They're going to be much more instantaneous, much more real time, if you will. Okay, so the next thing I'd like to do, now that we have a little background on what 5G is intended to be and where it's going, I'd like to compare and contrast it. For example, let's compare and contrast it with the current iteration, 4G LTE. Okay, 4G LTE is really where we're at today. And these are the improvements that you can kind of expect. First of all, an improvement in speed, up to 10 times the speed that you're accustomed to right now with 4G LTE. That's a big improvement. In terms of latency, please forgive me. This slide is backwards. 4G can deliver as much as 4 milliseconds of latency, which is not necessarily perceptible, but it's a lot. 5G latency doesn't ever exceed 1 millisecond. And somehow I built this slide backwards. Apologies. Capacity. Whereas 4G will support up to 100,000 devices, 5G, each 5G network will support up to 1 million, 10 times as many devices. So much more capacity in a 5G environment. In terms of the frequency ranges that are in use, for those of you who are interested in that, 4G uses lower than 6 gigahertz ranges. 5G uses ranges from 30 gigahertz all the way up to 300 gigahertz. The reason being having to do with the way in which carriers obtained the bandwidth needed to build their 5G infrastructures. They vary pretty widely, and they came from a lot of different places, the history of which would take up a session all into itself. But suffice it to say that they're all approaching it differently, and that's why there's such a broad scope of frequencies in use. Complexity. There is definitely some complexity to 4G, but honestly, not much. When it comes to 5G, you'll be smacking yourself in the forehead and saying, "Oy, it's going to be complex for a long time to come." 5G is going to be a steeper learning curve over more time, just because of the way in which it's coming together and the expectations. To fulfill those expectations, it can't possibly be as easy as 4G LTE has been. In terms of security measures, we've gotten some good security out of 4G, but we're going to get even more out of 5G, and a lot of that is yet to be rolled out. So keep an eye open for it. Network slicing. Right now, for every application of 4G that you're going to be using, you have to build another network. If 5G, you're going to be able to slice up one given network into multiple slices and use each slice for a different application. Much more flexible, much more cost effective. Actually could end up being less complex because it's just one network, but we will see. So with 4G, you need a new net for every app. For 5G, no new net. And then price and availability. Okay, if there was ever a moving target, it is availability. 5G, according to each carrier, is most available from them and less available from the others, no matter which carrier you're talking about. So availability is a crapshoot and will be until full deployment is achieved, which is going to take some time. 4G availability is terrific. You can expect that it will be terrific for at least another 10 years to come. That's how long it's expected to take us to transition from 4G LTE to 5G. Price, the only way I can express it right now is that the average price of a 4G LTE account is about $68 a month. The average price of a 5G account is about $89 a month, 25% more. Personally, I expect that to get narrower. I expect 5G pricing to come down dramatically as more devices become available and more demand gets generated, and more of the carriers want to see more of their customers making the switch, and they want to give them incentives. So keep an eye out for that, but I think we'll see price come down. We'll see availability go up over the next few years. Okay. So now we have compared 5G to 4G LTE. Next up, let's take a look at how 5G compares to Wi-Fi. And this is somewhat of a Wi-Fi forecast for 2023. Okay. First up, we can expect, just as we can expect to see 4G LTE continue, we can expect to see Wi-Fi 6 continue to grow, especially with the extension in Wi-Fi 6E. It delivers terrific throughput, reduced latency. It's a good performer, and we expect that it will continue to be a good performer and continue to enjoy great acceptance. However, we do expect Wi-Fi 7 to arrive earlier than expected. Wi-Fi 7 is under development even now. It's estimated that the IEEE will approve it by sometime in May of 2024, maybe the beginning of 2024, and that devices will start to roll out in early 2025. So we'll be shifting from 6 to 7, but again, 6 will be with us for a long time to come as we make that transition. There will, of course, I mean, what presentation wouldn't be complete without a complaint about the current supply chain issues? You know, it was because energy prices and fuel prices were rising, and people couldn't get component parts, and people couldn't get raw materials. And the fact of the matter is that that's all changing now. Energy costs have been plummeting. Fuel costs from specific countries has basically evaporated because everybody's going elsewhere, and the competition is breeding price reduction. So we're seeing things free up. We're seeing raw materials become more available. We see people returning to work. So although there will continue to be supply chain issues to construct all of these different devices that are needed, we see that abating. We see it getting better. So look forward to improvements in supply chain. There are new offerings coming out, several of them. Open roaming is from the Wireless Broadband Alliance, WBA, and it really connects hotspots. And we're expecting it to go to lots of hotspots so that you can roam effortlessly and the switching will take place for you. Momentum is a brand name for one of those. What else do we have? We have, TIP Open Wi-Fi. Meta, formerly Facebook, has been deeply involved in the development of Open Wi-Fi. Open Wi-Fi is basically kind of like WiMAX, I guess, in that you have Wi-Fi access points deployed everywhere, and there's no security on them. They're completely unprotected. It is anticipated that all of the authentication and authorization will take place at the back end where the user is going rather than at the front end where they're entering. Should be interesting to see. It's said that now that Meta is starting to back off of it and transition it over to other organizations to further develop. We will definitely see what happens with it. Then there's automatic frequency coordinator. Well, it's a mouthful. AFC is really required for applications where connectivity needs to be available indoors and outdoors. So it bridges the two. It's in the 6 gigahertz range. So there is actually plenty of bandwidth available for it. It's not widely distributed yet. There are something like 13 organizations that are working with it. But again, something to keep our eye on for future development. A new offering that we can consider is the convergence between Wi-Fi and 5G. Lots of questions here. Will 5G be the long haul and then Wi-Fi the last mile, the way it is now with 4G LTE? Will we be connecting desktops just with 5G? Will we simply phase out Wi-Fi in preference of 5G doing everything? That's actually a live argument, and everybody has a position on it. Everybody has an opinion. I will not express one here because it's just too soon. But a big focus of that, of course, is focused on convergence within the enterprise. How are they going to do it? So we'll be interested in seeing that. Now, I'm not sure if I should be pronouncing this Halo or Halo, but this is based on the IEEE's 802.11ah standard, which operates in a very, very low bandwidth range, sub gigahertz, with a much narrower channel. So there are certain environments in which this will be tremendously helpful, smart homes being one of them. But we'll have to keep an eye out to see that also. These are all more brand spanking new than 5G. Then there is the metaverse itself. Let me start by saying that many of my fellow analysts are out there predicting that the year of the metaverse will be 2030. We've still got 7 years to go. There are other analysts who say, yeah, that will never come. There will never be a year of the metaverse. Opinions range widely. I have not really done enough research into how people are using the metaverse right now. I only know what they intend it to be, and that's not something you can base a decision on. But it does require tremendous bandwidth. I mean, think about it. You're rendering moving graphics constantly across a wide connection. That's huge. It requires huge bandwidth, huge processing power. You know, we think of it as cartoons moving around in cyberspace. Technically, it's much, much more. And while AR and VR are gaining more and more acceptance, the metaverse may find a place in that. If it does, it's going to be at a cost. We're going to have to provide it with everything that it needs. Finally, we can all expect to be impacted in some way, shape, or form by the monetization of Wi-Fi, which is in and of itself going to be a challenge. Some providers are tying marketing and analytics to their services to monetize. Others are trying to vend certain location-based services to add to Wi-Fi. And there are other limited applications, but offloading services and whatnot. We will see more creativity, certainly in 2023. And if the carriers are successful, we will pay for that creativity. Okay, so now we have compared 5G with 4G LTE, and we've compared 5G with Wi-Fi. What else is there? Well, to be complete, we have to compare 5G with 5G. The fact is that there are 3 different types of 5G. And as I said before, they were each developed according to where the bandwidth for them was sourced. But it led to the development of a low-band 5G network, a mid-band 5G network, and yep, you guessed it, a high-band MM wave. MM wave is a name they gave it, high-band 5G network. In summary, just to pull it all together, this is another slide. This is a bad deck for me. A couple of typos here. This is about 2% faster than 4G LTE. Maybe in next year's presentation it'll be 20. But right now, low band is about 2% faster than 4G LTE. Mid band gets you up to 6 times faster, but it's a smaller footprint. You've got to be closer to the antennas. And so you get the 6 times faster. Then finally, as you can imagine, high band gives us that magic 10 times faster. Ultra low latency. There have been many complaints by users that when they use 5G now, they're not seeing any reduction in latency. And that's because we haven't gotten there yet. The 5G you're seeing today is a hybrid. We'll touch upon that in a moment. But you've got to be close to a tower or a transmitter to get that ultra low latency, which if we're using this for autonomic vehicles and stuff like that, there's going to have to be an awful lot of antennas and transmitters, towers and transmitters, servicing the roads. Otherwise, we're not going to be able to do it. So that's the story. There's always a cost for getting more bandwidth and getting lower latency. If we look at the carriers and how they've deployed so far, T-Mobile already had a low-band 5G network and a smaller, faster, high-band 5G network, an mmWave network. When they merged with or acquired Sprint, depending on how you look at it, that added a mid-band network. They had 2 very different kinds of technologies, and many think that that's one of the reasons the merger took place. They are now the only carrier that has entries in all 3. So you could say that they've gotten a jump start on everybody else. Verizon currently sports a high-band network, which has not yet achieved tremendous availability, but it's on the way. And then AT&T has high-band and low-band. And again, what we see now is 5G Plus suggests again that it's not really totally 5G. We can guess that this is going to change. Even in 2023, it's going to change because they're all going to look at how they're competing and decide that they have to do things. They may have to develop new technologies. They may have to acquire new technologies. We may see more merger activity. It's hard to say which one's going to happen. But when we look at all 3, there is one thing that we can be guaranteed of in 2023, and that'll be continued confusion. There's plenty of confusion around 5G because it's not really there yet. Everybody was in a rush to roll it out, but the fact of the matter is that today's 5G is absolutely supported by 4G. A non-standalone 5G network, meaning a broadly available metro kind of network, has to have 4G as its anchor. Why? It uses the existing infrastructure. If they had a way to build out all of the new infrastructure required for true 5G, it could be years. So It also helped reduce their cost of deploying. And of course, all carrier costs are passed right on through to you, the consumer. It absolutely sped up their deployment timeline so they could get to market at the same time as or before their competition. Now, of course, in 2023, we're going to see the first year in which 5G truly stands alone. And so the new 5G will have a 5G core and the new radio technologies that are being developed specifically for 5G. So at the core and on the air, all 5G, 5G from end to end, will happen in 2023, has not really happened yet. That's when we'll see this truly low latency. And again, you'll have to be near the tower, near a transmitter, to get that low latency. So we're going to see higher densities of towers. This is when we'll see network slicing enabled, and there'll be more flexibility in how many things you can do with a given 5G circuit. One thing to remember from a purely physical logistics standpoint is that 5G requires fiber for its backhaul, its mid-haul, its front haul. When you get back from the tower to the network core, that's all got to be fiber. And so there's going to be a lot of work to be done just to get everybody's land networks ready for the true arrival of real 5G. Now, we can expect real standalone networks to unlock 5G's true potential this coming year, this year in 2023. This is kind of what it looks like. That is a 5G tower antenna servicing a city. You can actually see another one in the distance, which gives you some sense of how close they need to be to each other. But with macro cell, this is macro cell, big cell, you'll have metro area 5G. And you can be walking down the street and using your phone to pick up 5G network service. It'll be separated into segments that serve the internet per se, construction and engineering applications, and also a distinct segment purely dedicated to cloud. So we look forward to seeing more rollout of true macro cell 5G. At the same time, we'll go back to small cell. So here you see on a lamppost a small cell repeater, if you want, operating, connecting to a macro cell, but providing more concentrated bandwidth near itself, and less concentrated even a little bit further away. So users will get a better experience with the deployment of small cell than without it. Now, this image screams smart cities, but you can also apply this to the enterprise. You can almost bet that small cells will, to some extent, replace Wi-Fi access points. Enterprise will be deploying these throughout their premises, throughout their buildings, to give everybody better connections. They may eventually abandon their hard-cabled infrastructure completely because they have such reliability in these devices. But again, that remains to be seen. None of these answers are clear yet. And then finally, oh, by the way, this is what small cell devices look like. They're already out there. Finally, for the big, broad swath of people, FWA, fixed wireless access, and it promises to enable 5G for everybody. You know, we talk about bringing broadband to the entire country, and new initiatives like the Infrastructure Act absolutely fund and help that effort. Fixed wireless access is going to be a boon to this effort. Basically, anybody who's using it, whether it's in a small industrial park, a private home, a farm, what have you, they'll be erecting an antenna, and that antenna will speak to a fixed wireless tower, which will speak to all of the antennae in its area. And then that fixed wireless tower will go to the fiber backhaul tower, which will then connect to the land network that brings it back to the core. Fixed wireless access is a big deal. This is true standalone access using 5G. And there's a lot of excitement around here. The applications are tremendous. And it'll be interesting to come back 6 months to a year from now and see how all of this is progressing. John, that's my report on...
I'm going to hold you to that, Howard. We're going to bring you back
wireless
and see
network.
Where we...
Yeah, believe me, I will love to do that.
Well, we would love to have you back. But in the meantime, let's get to some questions from our attendees. Remember, guys, you can type your questions into the Q&A box at any time. We'll do our best to get to all of them. Okay, here's one from Anne, and she's wondering if there are 3 different 5G standards, how do we choose which one to use?
Oh. Honestly, Anne, you're asking me that question a little soon. They haven't been completely rolled out yet. But my anticipation is that telecommunications experts and IT experts will be able to provide the same kind of consulting that they do today on different kinds of servers and routers and switches and other premises equipment. They'll be able to tell you which better suits your specific application, because the reality is there is no right choice. There's a choice that's right for what you need. If you can tolerate being close to a tower, then there's one choice available to you, like high band. If you can't, then you may have to look at low band or medium band. There are lots of parameters like that that are all going to have to be taken into account before you can really determine which is going to be best. And remember that things change. Your needs may change. The standards may change. So I think we're very early in the process, but it's going to be the same kind of analysis you do today when deploying regular networks for anything.
Okay, Zeke is wondering, which of these supports driverless cars?
None of them. Right now, you won't catch me dead in a driverless car. Actually, my BMW stays in lane, but it's not because of 5G. It's sensors in the road. It's actually cameras that are looking at the lines drawn on the road, so don't be fooled. But autonomous vehicles require literally zero latency. Think about it. You come up to a corner in your driverless vehicle. The vehicle realizes that it needs to pause before it makes a left turn. So now it's signaling its left turn, and it's looking in front of itself to see if there's oncoming traffic. Real good. And when the oncoming traffic passes, it'll then make its left turn. What happens if the connection between it and the core stops? What will it think? Will it think, oh, I'm clear to go, and you get smashed? Or will it think, oh, I'm not clear to go, and keep you there for a while? Either way, that's dangerous. And so until we have true, and at this point I'm going to guess that it's going to be true high band, wave 5G, and we do get the latency down to virtually zero, autonomous vehicles are still going to have the same kind of news reports that we see today.
So this is from Eric. He's wondering, besides small cities, where else do you see small cell being useful?
Well, I mentioned in the presentation, and to me, this is really, I think it could be the primary use of small cell. I see people deploying small cells on every floor of their building. The way that they deploy Wi-Fi access points right now. The advantage being that today's Wi-Fi access points have to be hard cabled. back down to a router somewhere in the building, whereas small cell will just get hung up in the air there. It'll be much easier to deploy. Small cities, forget small cities, big cities. I mean, enormous cities are undertaking smart city initiatives. Barcelona is not a small city. San Francisco is not a small city. These are the guys who are in the vanguard of creating smart cities, and there are plenty more. Small cell is very scalable. You can deploy more devices. I mean, if you just use the lampposts as a backbone, you could be deploying them on every other lamppost or every lamppost, however you want to do it, and creating a really powerful, highly available network. So, and where these small cells can back each other up, so it's very resilient too. I think we're going to see lots of applications for small cell, and even more for FWA.
Okay, we've got time for one more question for Howard. This is from Nestor. He's wondering, are you saying you see the entire copper infrastructure becoming obsolete?
Well, I hope not, Oscar, and I'll tell you why. I live in Arizona, which is also known as the Copper State. So if copper becomes obsolete, well, then our biggest industry kind of goes away too. Copper right now is very valuable. There are people who strip copper to make a living. I don't know. I know there'll still be applications. There's tons and tons of copper. A lot of it deployed originally by the Department of Defense in the early 1970s. But there's a lot of buried fiber now, too. And a lot of it is dark. I see it getting all lit up. I see us getting incredible bandwidth and incredible speeds and responsiveness. And copper will have its place, but I think the predominance of copper will shift to being predominantly fiber. And copper will do its thing. Did you know that we're the Copper State? Yeah. So I didn't.
So go ahead.
No, I'm done.
Well, I didn't mean to interrupt you. We had kind of a rush of questions here at the end, and I think we should take some time to squeeze them in. So this is from Barry. He's wondering, is there a rationale for staying 4G and slowing the transition to 5G?
Absolutely. Absolutely. I come from the era where they said never install .0, right? Never install .0. And I still believe that. 4G LTE has the wonderful added feature of it works. It works well. It has worked well consistently for years. We all depend upon it. 5G is new, and everybody is vying to be the leader in 5G. And now being the leader in 5G brings with it being the leader in determining which technology in 5G remains. And that's not a given anymore. So I would take my time. I would take plenty of time. I would, follow all the publications we follow what's going on at the three major carriers, and expect that there's going to be a fourth or fifth sneaking up from behind with all kinds of new ideas that may just put the others on their heels. I wouldn't do a complete rollout of 5G in 2023. I would watch the progress and then start making decisions once some of the things that I've suggested here actually come to pass.
So here's a question from Cosmos. He's wondering, will you be able to use all three types at the same time?
I'm going to interpret that question. I don't know why one would have a single device using all three. I don't know that there would ever be an advantage to that. There might just be confusion. But an organization could certainly have applications that are best served by low band, others that are best served by mid band, and even others that are best served by high band. Again, it's all based on the application and how the application is best served. But yeah, an organization could be using all three.
So here's one from Johnny, and this is a question that we hear surprisingly often. With the 5G towers being so close together, how much concern is there in regard to negative effects on the human body? He's worried about cancer and radiation.
Yeah, and I am too. I have not done the homework on that, and I apologize because that is important. I moved here from Long Island, which is famous for its little cancer clusters. It's a horrible thing.
Yikes.
Yeah, and I gotta think that there are reports on how the 30 to 300 gigahertz bandwidth range impacts the human body, because that's really what it's based in, right? Microwaves, deadly. Low band waves, like for this, under 6G, yeah, that might work. But I don't know. I have not addressed that yet. But thank you, because it's something that I do want to address.
Here's a question from Darshak. Hope I'm pronouncing that right. Is it true U.S. has fake 5G? Is it not really at 5G speed compared with other nations?
First of all, it's not just U.S. I don't believe at this point. I mean, some nations are moving faster than others. My guess is that, as it always happens, France is in the lead. They've been in the lead on everything every time, but I don't know. But I wouldn't describe it as fake 5G. I would describe it. I would prefer to describe it as early 5G. As I pointed out in the presentation, 5G absolutely depends upon 4G LTE infrastructure to be an anchor for it, to be a support for it. That's happened with many technologies over the years that we continue. I mean, not for nothing, but what version of Windows do you think doesn't have at least some elements of the original DOS kernel? We haven't used DOS in 40 years. But I would bet you that there is some DOS still in there. We all build our technologies on the base of previous technologies, and that's a good thing. So I wouldn't call it fake. I would just simply call it early.